discuss the matrix in transformation. Consider this xy coordinate plane. Point A has the coordinates 1, 0, and the point B has the coordinates 0, 1. We rearrange the coordinates of the point A and B into a matrix form, where the coordinates become the x and the y components of the columns A and B. We learned that this matrix is what we call as the identity matrix. Under a certain kind of transformation, we'll be identifying the new matrix that describes that type of transformation, with the columns A', B'. Consider this example: reflection through the x-axis. Again, the original points have the coordinates 1, 0, and 0, 1 for the points A and B, and we rearrange these coordinates as the xy components in the matrix form of the column A and the column B. Under reflection through the x-axis, let's identify the new matrix. This is the mirror line, the x-axis, or y equals 0. After the reflection, the point A remains in its position, and we call it A'. But the point B is being reflected, and we call it B'. So the coordinates of the points A' and B' of the new image are 1, 0, and 0, -1 respectively. This would become the x and y components of the new matrix for the A column and the B column. And this is the matrix that describes the transformation reflection through the x-axis. Let's have another example: reflection through the y equals -x. Under this translation, we'll determine the new matrix. This is the mirror line y equals -x. The point A will be reflected on this location, A', and the point B will be reflected on this position, B'. So the coordinates of the 2 points A', B' of the new image are 0, -1, and -1, 0. And these are the x and y components of the matrix for the A' column and B' column. This matrix represents the transformation under reflection through the mirror line y equals -x. Let's have another example: rotation of 90 degrees clockwise at the center 0, 0. Under this transformation, let's determine the matrix. For 90 degrees clockwise rotation, the point A' and the point B' are located on this point. The coordinates are 0, -1, and 1, 0 respectively. These are the xy components of the matrix under A' column and B' column. So this matrix represents the transformation rotation 90 degrees clockwise at the center 0, 0. Let's have another example: rotation of 180 degrees at the center 0, 0. Under this transformation, let's determine the matrix. This is the rotation of 180 degrees. And these are the location of A' and B'. The coordinates are -1, 0, and 0, -1 respectively. These are the x and y components of the matrix under A' column and B' column. And this matrix represents the transformation rotation of 180 degrees at the center 0, 0. Another example is enlargement at the center 0, 0 with a scale factor of k. Under this transformation, let's identify the matrix. We can represent the enlargement through this: k times the coordinates of A and k times the coordinates of B, which lead to the coordinates of A', k0, and the coordinates of B', 0k. These are the x and y components of the matrix under A' column and B' column that represents the transformation enlargement at the center 0, 0 with a scale factor of k. Let's use these matrices to identify the coordinates of the points of the new image under a certain transformation. For example, rotate triangle ABC 90 degrees clockwise at the center 0, 0. 90 degrees clockwise at the center 0, 0, and the location of the points A' and B' are this. The coordinates of A' are 0, -1, and for the B' are 1, 0. These are the x and y components of the matrix under A' column and B' column that represents the rotation 90 degrees clockwise at the center 0, 0. Let's name the points A, B, C of the original figure based from the center 0, 0. A is -5, 6, B is -5, 2, and C -2, 2. And we arrange these coordinates into a matrix form, a 2 by 3 matrix. The matrix that represents the rotation 90 degrees clockwise at the center 0, 0 will be multiplied to the matrix that we made out of the coordinates of the points of the original figure. Review on how to multiply the two matrices. After doing the multiplication of matrices properly, we'll come up with this matrix. 6, 5 would be the coordinates of the A prime, 2, 5 are the coordinates of the B prime, and 2, 2 are the coordinates of the C prime. So we can now plot these 3 points on the xy coordinate plane. For A prime, 6, 5. For B prime, 2, 5. And for C prime, 2, 2. And this makes the new image of the original figure ABC under the rotation 90 degrees clockwise at the center 0, 0.